There's a buzz in the food industry about new emerging technologies related to biofilms, and I've done an earlier interview on this topic with an EHEDG company member that is developing a new type of biofilm sensor. And today I am talking to a representative of a collaborative research project between the University of Natural Resources and Life Sciences in Vienna, in short BOKU, and the Fraunhofer Institute for Process Engineering and Packaging in Dresden. With us is Dr. Elena Zand. Thank you for joining us today.
I'm very glad to have the possibility to talk about our recent project on biofilms. And yeah, very happy to be here.
All right, let's do it the scientific way by first defining what we're talking about. Can you give us a scientifically correct definition of what a biofilm actually is?
So a biofilm is actually an aggregation of different microorganisms, or especially also like different bacteria that are like growing on a surface. And in this form, in this aggregation, the biofilm is way more resistant against external forces, like against chemicals, mechanical, or also physical forces, compared to the planktonic form. So compared to single floating bacteria within the production line.
The name of your research project, Biomitate, refers to your aim to develop an artificial biofilm for rapid cleaning control in the food industry. Why would the food industry need to have an artificial biofilm to do that?
The overall aim is to efficiently remove the biofilm, the real biofilm. However, it is clearly not possible to introduce a native biofilm within the production process for testing different cleaning strategies. So if we would do this, we would contaminate the production line. And of course, we don't want that. So one option to efficiently test cleaning strategies is to use artificial biofilms, or rather biofilm imitates without microorganisms.
How does biofilm formation relate to the area that EHEDG focuses on ultimately, and that is, of course, hygienic design?
It's not only the hygienic design, it's also the cleaning strategies. So it really depends on what chemicals we are using. And then it also depends on kind of the routine. How often are we cleaning, or how often are the pipelines cleaned within the food industry, and what kind of concentrations of the chemical is used. So there are actually many different factors that are affecting the hygiene, and with this, if the biofilm can be removed or not.
Or not, indeed. That's what we want to find out ultimately. We want to know if there are areas in the food processing line where biofilms can develop, and to find out if these areas are cleanable, even if biofilms already developed there. That's where your biofilm imitate comes into play, right? What does this mean ultimately from a technical viewpoint? How are you managing to create a imitation of a basically biological structure here?
So the goal in our project is to develop a biofilm imitate that has the same cleaning relevant properties as the native biofilm. But this imitate is microorganism free. So what we try here is to use other components, also, for example, other polysaccharides that are also present in the native biofilm. And besides the polysaccharides, we are also adding different salts, for example, like calcium, magnesium, potassium chloride, to get a gelling effect of this imitate. And then we characterize the imitate and compare these characteristics to the native biofilm to make sure that the cleaning relevant properties are comparable.
What is the current stage that you're in this research and development project?
So currently we are characterizing the developed biofilm imitate models, so the artificial biofilms, and compare their cleaning relevant characteristics to the native biofilm. And here at the University of Natural Resources and Life Sciences, we focus on characterizing the rheological behavior of the biofilm imitates, on the physicochemical properties like the wettability and the surface free energy, but also on the adhesion of the imitates on different surfaces and also on their mechanical stability. And at the same time, our research partner, the Fraunhofer Institute of Process Engineering and Packaging, they focus on different methods to apply the biofilm imitate to such a substrate, like, for example, to a stainless steel substrate. And this is essential because the native biofilm grows on a surface, but it is currently still a challenge to reproducibly apply the microorganism-free imitate to such a substrate. So therefore, it is a basic requirement to be able to compare the imitate to the native biofilm in cleaning tests.
I'm sure that our viewers want to know one thing. When can they expect to be able to use the first artificial biofilms for their cleaning testing?
Well, it's always difficult for us to estimate a timeline when the imitate, of course, will be on the market for sale. I mean, we already have biofilm imitates, so someone could, of course, test them. They are already available, but we are working in kind of a feedback loop with Fraunhofer Dresden. So they are then testing the developed biofilm imitates for the cleaning trials. And if they see that some characteristics of the imitate are not working yet or are not realistic enough, let's put it like this, then we will kind of optimize and adjust the imitate, and then they will test it again. So that's where we are, or that's the work we are doing currently.
Dr. Elena Zand, researcher at the University of Natural Resources and Applied Life Sciences in Vienna. Thank you very much for this interview.
Thank you very much, Rob, for inviting me. And also, I'm very glad to have the opportunity now to talk about our current project, Biomitate, and in general, I'm also very glad to talk about my passion, biofilms. Thank you.